Welcome back to Huawei Routing and Switching Elite Training for HCIE. Today topic we are going to discuss on OSPF. Let's start our part 4.
So in this case, what type of situation you will get the full and a two-way. So when you're under the point-to-point and point-to-multi-point, all the routers always under a full stage. Under the two-way stage, because of we have a DR, a BDR, so within the broadcast and also MBMA, between DR others will form two-way state. Okay, this need to be aware. For DR others, they only form a two-way state, and they will form full stage to the DR and also a BDR. Alright, these are the two different relationships in the OSPF. So next, let's look at the special areas. Special area, just now I mentioned to you, on the special areas we have a stop no summary, no sum, NSSA, no sum. So in what type of situation they will having the special areas? So when that, let's say let's look at this example on the area 1 and the area 2. Maybe on these areas they cannot handling too much of a LSA information. So I want to make the area 1 or area 2 become a stop or the totally stop areas. When I have a stop areas, on area 1 I stop areas, R2 will just send the type 3 specific and also a default LSA. So they will send the default route to R3 to allow R3 go to the external route that R1 performing the route import. So I can still reach to the ISIS through the R2, and R5 still can go to the rest through R4. But because of R5 as a totally stop areas, I only can receive LSA type 1, type 2, and a default route. Alright, so in this case, for area 2, want to go to R3, I need to going through a default route as well. So when a totally stop areas, they will just having the LSA type 1 and type 2 and a one default route pointing to the ABR routers. And remember, when you're under the stop areas, either stop or NSSA, always filtered type 4 and type 5. Type 4 and type 5 you will not see inside the special areas. So these are the 4 special areas that we're going to cover. Then this one is called a stop areas and the totally stop areas. So what's the difference when compared to the NSSA? On the NSSA, I can perform the import route. Let's take this as an example. On R3, R4, they're running as an NSSA. R4 connecting to the RIP. When I perform the import route, R4 as an ASPR. When ASPR detected you have a LSA type 5 coming in, I convert to become type 7 and send across to the area 0. So R3 you will receive the type 7 LSA, so R3 as ABR. When ABR receives the type 7, you convert to become a type 5. And R2 you send as a type 5 as well. But when R1 perform the import route, I have type 5 to R2, R2 will send to R3. But when R3 Will R3 send the type 5 to R4? No, they will not, because NSSA filtered LSA 4 and 5 is not allowed. So it means that R3 will not convert the type 5 to become type 7. The type 5 to become type 7 is only happens on the ASBR routers only. So it means that only R4 will generate the LSA type 7. So this is the difference when you compare the NSSA and the stub areas. So NSSA, they always have a new LSA type called LSA type 7. This is only happen on the ASBR routers. Okay, next. Okay, next we're going to cover on the OSPF Convergence. On the OSPF Convergence, they're always based on the fast convergence. They have the incremental shortest path first, partial route calculation, intelligent timer. So within the fast convergence, for the incremental shortest path first, is calculate the route only for the affected node. It means that right now you had added a route. In this case, they will just go for the incremented shortest path first instead of they go for the entire full shortest path first. They go for the incremental shortest path first. Calculate the route for all nodes during the initial state only. So for the full shortest path first is only for the initial calculation only. Any new route added in, they go for the incremented shortest path first. For the PRC, the partial route calculation, when your route change, they only you recalculate the route changes only. They will not go for the full shortest path first calculation. So they update the route based on the shortest path 3 calculated by the ISPF. Then next, for the intelligent timer, intelligently control the network instability cost and reduce the LSA flooding. If let's say right now I have a LSA flooding or my link is flapping, in this case I need to keep on sending the LSA information. With adjust the intelligent timer, I can set within few seconds I will not sending LSA information. Make sure that my network is stable, then only I will send the LSA information. And the last one, for the priority based conversion, preferentially converge specific route. So in this case, you can prioritize any route you need to converge first when your network have any changes. So this one is always based on your IP prefix. You can based on IP prefix to define which route you need to go for a fast conversion. You're going to giving to the higher priority. So this is on the OSPF convergence. And also for the OSPF extension features the database overflow. So for the database overflow, they limit the number of the non-default AS external route, prevent an OSPF database overflow. So what it means over here, if let's say R1, this R1 is a ASBR. So you want to make sure that limit the number of the non-default AS external route. It means that when ISIS come to me, they might generate a lot of route information, but it's non-default AS external route. It's come from the other routing protocol. So it might not all useful. All the route that's sent from ISIS to OSPF is might not all useful. In this case, I can set the limit of my LSDB database. So the routing table is full and cannot store more information. This is the problem. If let's say right now for this ISIS, I have 10,000 of the route going to import into the OSPF. you can imagine that all the route is not necessary. Let's say for router A, your ASPR routers is not do any filtering. All the 10K of routing table will be imported into OSPF. So to make sure that I prefer all my internal route, I will always set the database overflow. Make sure that you're preventing the OSPF database overflow. What happens when the database is overflow? In this case, I will first discard the non-default AS external. I prefer my own internal route, and I will discard the non-default AS external. So you can set the limit of the LSDB information. So you can set the limit to prevent the OSPF database overflow. And also second things, another extension features we call as a virtual link. So in what type of situation we need to use a virtual link? Virtual link refer a logical channel established between the two ABR through a non-backbone areas. And a virtual link take effect only when the virtual link is simultaneously configured on the two ends. And the non-backbone areas that provide an internal route for the two ends of a virtual link is called the transit areas. And the transit area cannot be a stub areas. So this is the point that you need to understand why we need to using the virtual link. So let me give you an example. Let's say right now I have 5 routers over here. So I have 5 routers over here. So over here, so in this case, in total they have 3 areas. So let's say over here is area 0, area 1, and also area 2. So first thing, we need to make sure that you understand the backbone areas. Backbone areas is also called as a transit areas. So when right now in this example, area 1, this area 1 is a transit areas? It's not. So for area 2, the router in the area 2 will not able to go to area 1, and also is not able to go to area 0, because in the middle we must make it as a backbone areas. We need to define the backbone area in the middle to perform the transit areas. So in this case, what we can do, let's say you have area 0 on the left, area 1 in the middle, area 2 at the right. So let's say you want to allow the area 2 talk to the area 0. So in this case, you have to do it like this. You need to define a V-link, a virtual link between the two ABR routers to perform a V-link. And a V-link is called as a transit areas, and also we call this as a area 0. So whichever routers you define the ABR on the V-link, you define on the ABR, you generated the area 0. So this is one of the example why we need to using the V-link. Remember, the non-backbone areas is not a transit areas. For the non-backbone areas, going to the non-backbone areas, we need to go to the backbone areas. This one you need to make sure that you understand. So, and also there's another example. So let's say right now, I have 4 routers here. So I have 4 routers. I have an area 0, area 1, and area 0. So do you think that over here, let's say this is the routers A, B, C, and D. Can router A talk to router D? The answer is no, it can't. They cannot communicate because area 1 is not a transit areas. So in this case, let's say you want to allow this area 0 and area 0 talk to each other. Between router B and router C, you need to define the virtual link to allow router A talk to router D. So this is the virtual link. Alright, so virtual link, and you remember virtual link cannot be a stub areas. So in this example, for area 0 R1 talk to area 2, so you need to define a virtual link between R2 and R4. You define the V-link connection between the R2 and R4. So these are the extension features on the OSPF. And next, the last extension features as a authentication. You still remember that authentication, when we talk about hello packets. So authentication is one of the rules for them to become a peer. So you need to make sure you define the authentication in your hello packets. By default is none. They will not enable authentication by default. So let's say you want to enable authentication. They have 2 different types and they have 4 different modes. So they have 2 types: interface authentication or the area authentication. Then there are 4 different modes now: simple, MD5, and a HMAC MD5. These are 4 different modes of the authentication. So let me change the color. So what I mean by the based on interface and based on areas. So let's say right now, so let's say this is area 1. So within the area 1, I want to perform based on interface. When based on interface, within a single areas, I just have to define the authentication on the interface. Alright. When it's areas, it's entire areas. So it means that you need to define on the areas. Area 1 authentication means all the routers have to configure the area authentication. So you need to make sure that in the OSPF they only will prefer one authentication. Okay, only perform one authentication. So always they'll prefer based on your interface authentication. They prefer your interface authentication. Let's say you have no interface, they're based on the areas. So what happened is, let's say right now I have this situation. So I have 4 routers. So I have a area 0, area 1, and also area 2. Let's say I want to perform a area 0 authentication. So which routers I need to perform the authentication? Let's say over here I have a virtual link between the two area. Let's say this is router A, B, C, and router D. So let's say I want to perform the area 0 authentication. I need to configure on router A, router B, as well as router C on the virtual link. I need to perform authentication on the virtual link authentication, because VLink is also equal to area 0. So you need to aware of this. Need to perform on the VLink as well. Let's say they were looking for the area 0 authentication. And these are the 4 modes. Now, simple MD5 and the HMAC MD5, they can perform the authentication mode. Alright.
Thanks for watching. Please do not forget to subscribe to our channel.